All right, problem solvers. This is our second lesson that we're doing for virtual learning. You guys did functions, and now we're doing algebraic manipulation. This is a shorter PowerPoint that really is just kind of to remind you of some tricks from pre-calculus or algebra 2, and we're going to use them in kind of weird ways, but there's not a whole lot to say here. But some important things, look for elegant solutions, think about kind of clever factoring or ways things can work out nicely. Some things you might have to grind out, but if you're grinding out a problem, you might have missed kind of a nice way to not expand something all the way out, but maybe do a factoring while it was already partially factored or something like that. So try to avoid ugly manipulations. I'm not saying that those are never going to work, but that's usually not the aim. Some advice, factoring is number one way that these problems are going to go, so try to factor relentlessly. Creatively add 0 to make factoring work. Know how to create and recognize perfect squares. If you don't remember how to complete the square, that's something that you should look up. Feel free to Google that. Use symmetry. Binomial examples. These are all coming from Pascal's triangle. You can see the pattern there. 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Also, you are free to Google Pascal's triangle if you don't know what that is. It's helpful. The only thing different here is keep track of the plus or minuses. So just to recap so far, things I've suggested that you Google would be completing the square in Pascal's triangle. Binomial formula gets pretty gross. By the way, we haven't really hit permutations and combinations much, but that's what those are on the left. But again, you don't need to memorize this because you can usually do this. You can use Pascal's triangle. That's kind of the shorthand way to do this. Here's some factoring examples. Make sure that you know the formulas for difference of squares. So the first one is difference of squares, and then on x to the fourth and y to the fourth, they use it again. And then a difference of any power is always going to have some sort of linear factor. You can notice that all of these have an x minus y or an x plus y. But then difference of cubes, I learned SOAP, same opposite, always plus for the signs, but just make sure you know how to the fact that a difference and a sum of cubes always factors. Sum of squares doesn't factor, sum of quartics doesn't factor, but a sum and difference of cubes will factor. So you might want to come back to this if you forget. Some general factoring, you can do this really for any power. But like I just said, the second formula only works for odd n because sum of squares, sum of quartics, sum of powers of 6, those are not going to factor. That's messy to look at. I don't think you'll need to get quite to this level. And again, you can come back and reference this stuff if you need to. So in case you don't want to Google completing a square, here's an example. So I want to factor x to the fourth plus 324. It's the sum of two squares. The middle term would be 36x squared. So what they did, you might have learned to take half of something like k over 2 squared, if you remember that kind of phrase. What they did is, hey, if you needed the middle term for this nice square, you would have 18x squared doubled, which is 36x squared. So they creatively added 0, they added 36x squared and subtracted it. And then they did a difference of squares. The first thing factors from the square we tried to make it be, and then 36x squared is the square of 6x. Then you can do a difference of squares on those, and then you get the final version. This is not how I learned to do completing the square, so I would have whichever way you're comfortable with. Even at the bottom, there's the Wikipedia reference. I would just go back to completing the square the way that you learned how to do it.